Elizabeth. Good afternoon, everyone. Well, it's my pleasure to share the experience on Sambriog. I'm going to go to discuss, following the nice introduction from Elizabeth last Tuesday from the keynote lecture. I'm going to talk a bit about the design substantiation work and provide a little bit of feedback on the pile installation phase. Sambriog is a rocky site, and it has a dike swarm, it has a faulted area, some areas subject to shear, and also the stratigraphy is subject to varying degrees of weathering and jointing in the rock. So to give you an example, these are the sedimentary rocks that you find in Sambriog. These were the preferred rock types for placing the foundations. These are in greater number to find samples and tests, but also are to some extent more predictable in representing within the ground model. In contrast, you may find igneous rocks like dolerites or breccia conglomerates from the faulted areas, and also some metamorphic rocks like quartzites. These were less preferred, and sometimes we try to avoid them. This is a photo from the installation phase. You may see one of the jackets is slightly misaligned, and well, you may understand what I mean trying to avoid these rocks. Now, looking at the design, we've identified three main risks. First one was about understanding the pile behavior, how the loads will be transferred into the rock mass. And there was an onshore load test campaign to address that. However, we also recognized that the degree of variability in the rock was existent, and particularly considering the fact that there was typically one borehole per caravan location in a footprint of 25 meters. And also there were uncertainties in the pile installation. The key uncertainties with that in the installation were about understanding the socket roughness condition, understanding the implications of the drill tool into the socket and finding any excessive overbreaks, or equally effects in remolding in the surface of the rock or rock smearing. To give you an idea of the seabed conditions at the site, these are some photos taken in an inspection of one of the sockets that were used for going down the hole in an ROV and doing inspections. And you can see that the rock mass is highly fractured, highly jointed. There is varying degrees of discontinuities due to the bedding and the nature of the jointed rock. Going down into the hole, you can see the socket roughness is variable as well, and it's quite determined by the jointing nature of the rock. As you go deeper, you would expect a smoother surface roughness, but also we are mindful that these conditions are quite dependent on the jointing of the rock, and sometimes you may find some overbreaks. So looking now at the pile methodology, the design was completed using the offshore standard, the DNVGL ST0126, and taking the detailed ground model data to define the design basis. But on completion of that, we've reviewed the design and we said, well, what if there are things that we haven't covered from the ground model? So what can we think about that could go beyond our knowledge? So we started looking at the ground model confidence levels and trying to understand where the ground uncertainty was remaining in the current design. We looked at the rock mass rating to try to identify the existence of subvertical faults that would induce greater overbreaks. And we also carried out some correlation to understand the consistency of the geomechanical properties between locations presenting similar geology. So taking that site assessment, we carried out some sensitivity study to understand and say, well, if things go in a different direction during the installation, to what extent we can accept the design if we encounter that the ground is different to what we expected. So we used the working stress design factor of safety as a measuring parameter to correlate and understand the margins in the design. And we've, at the time of, well, close to the installation phase, we've taken some improvements in the cyclic load factors and the, well, some minor consideration on the pylon bearing, but equally we applied some model factors site-specific to each location to account for the variability or uncertainties in the ground model, and also to adjust the mechanical properties to be consistent across the global geological units. So to illustrate the results from this sensitivity study, we found that the longer piles with L/D ratios of about 9, within the higher degree of weathering and lower strength rock, those could accept a minimum factor of safety of 1.7. So having said that, we would expect that within some rock, once you reach a reasonable length by length, you know that you reach competent rock. So we were confident with that. But with the short piles, with the L/D in the order of 6, this is 18 meters from the seabed, we've considered that the variability of the rock could highly affect the factors of safety. So we've adjusted the pile lengths to achieve up to factors of safety of up to 3.1. So once the installation was complete, we reviewed the data from the drilling records, and the feedback was 4 out of 39 locations presented issues in the drilling. These were through either excessive refusal in the temporary casing, or evidence of overbreaks or lower mechanical energy. Looking at one of the locations as an example, location 51, we assessed the mechanical energy from the various drilling records, the drilling parameters, and we noticed that the energy applied at that location was, the frequency distribution presented a lower bound compared to the corresponding geocluster database. So going through a review on the engineering and some back calculation, taking some judgment on the as-built records, we concluded that the factor of safety at that location was reduced from 2.45 to 2.0. So the effective factor of safety ended up being 2.0, which was still acceptable. So in conclusion, the pile design was dedicated to understand the varying rock mass conditions. We used the model factors to account for the ground model variability, but also to correlate the geomechanical properties across locations with similar conditions. The installation was successful. However, there were reported a few locations with localized rockfall, and the drilling records also identify some lower energy, implying likely weaker rock than expected. So the margins adopted turned out to be successful to achieve an acceptable design, but we also are mindful that there are residual risks, and these need to be monitored over the operations and maintenance phase. And in terms of structural integrity, the actions for the operations and maintenance team are to carry out structural condition monitoring. There are 6 CMS across the jackets within the site, and also to establish the strategy for a digital twin analysis to confirm the jacket performance over the lifetime of the wind farm. So, yeah, that's Sambriok. Thank you.